Hello everyone, welcome back to Chemistry. Today we will be practicing few other questions from GOC chapter. Today we will be mainly focusing qualitative and quantitative analysis of elements in organic compound. So let's start the video. So the first question today is the best method for the separation of naphthalene and benzoic acid from their mixture. Now when we have been asked to separate naphthalene from benzoic acid, we know that naphthalene, anthracene, camphor, these are sublime substances. That means it can easily transform from solid to directly gas when they are heated. Now as compared to this, the benzoic acid is a non-volatile component. So sublimation technique is the best technique to separate them from their mixture, because one component is a volatile component, that is naphthalene, and another component is a non-volatile component, that is benzoic acid. And benzoic acid is a non-volatile component because it forms a dimer. So in this case, option B, that is sublimation, is the right answer. So my second question is, Lassaigne test is used in qualitative analysis to detect, and there are four options. Option A says nitrogen, B says sulfur, C says chlorine, and D says all of this. So in Lassaigne test, this element that is present in any compound, they transform from covalent compound to ionic compound by fusing it with sodium. So when in any organic compound the nitrogen is present, they fused it with sodium and we get sodium cyanide. When in organic compound contains sulfur, when we fuse it with sodium, we get sodium sulfite. And when in any organic compound there is any halogen group, that could be chlorine, bromine or iodine, we can fuse it with sodium and we get sodium halide. Now in this case, this cyanide, sulfide and halide compounds, when they heated with any distilled water, they form sodium fusion extract. So this is the complete Lassaigne test. So from this we can easily understand that Lassaigne test can be used for the qualitative detection of nitrogen, sulfur and halogen. So option D is the right answer, which says all of the above. So my next question is, in sodium fusion test of organic compounds, the nitrogen of the organic compound is converted into, and we have been given four options. The first is sodamide, sodium cyanide, sodium nitrite and sodium nitrate. Now in previous question itself, I have discussed what is Lassaigne test. So in this case, in Lassaigne test, when organic compound contain nitrogen, we started the Lassaigne test by fusing it with sodium metal, so that the covalent bond transform into the ionic bond. So when the organic compound contain nitrogen and we fuse it with sodium, we get sodium cyanide. So option B is the right answer. After Lassaigne test or sodium fusion test, we get sodium cyanide when organic compound contain nitrogen. So our next question says, the Lassaigne's extract is boiled with concentrated HNO3, that is nitric acid, while testing for halogen. By doing so, they have given four options. Now let me clarify what is the question. So it says that in case of Lassaigne test, when we get the sodium fusion extract, or while we get the sodium fusion extract, we heat it with HNO3, that is concentrated nitric acid, while we are testing, qualitative testing for halogens. Why do we do it so? So there have been four options. Now let me come that why do we do that. So in case of Lassaigne test of halogen, it is very necessary that we should remove the carbon and sulfur from the organic compound if it is present. So in case of Lassaigne test, if the organic compound contain nitrogen, it will form sodium cyanide after the sodium fusion, and in case of sulfur presence, it will form sodium sulfide. So both of this, when present along with halogen, it is very difficult to get the proper qualitative analysis of halogen. That's why we need to remove both of them before testing, qualitative testing for halogen. So that's why we treat it with concentrated HNO3. So when we treat sodium cyanide with concentrated HNO3, we get NaNO3 and HCN. Now this HCN is a gas and it will go out in the system. Similarly, when sodium sulfide is treated with concentrated HNO3, that is nitric acid, it will give 2NaNO3 and H2S. This is also another gas and it will go down in the system, and that's how we can remove the nitrogen and the sulfur from the system, and that's how only the one element that will left in the organic compound is halogen, and we can easily find out by qualitative analysis that whether the halogen is present or not. So that's why if our system contain both sulfur and the nitrogen, we need to treat it with concentrated nitric acid because it decomposes sodium sulfide and sodium cyanide that is formed. So option A is the right answer. So our next question says that Zeldal method is used for the estimation of, and we have been given 4 options again. It says nitrogen, halogen, sulfur and oxygen. Now in quantitative analysis, for the quantitative analysis of nitrogen, we use 2 methods. So for quantitative analysis of nitrogen, we use 2 methods. The first one is Dumas method. And the second one is Zeldal method. Zeldal's method. So now this question says that why do we use Zeldal method and for what estimation we use Zeldal method. So we can easily answer that Zeldal method is used for the quantitative analysis of nitrogen. So option A is the right answer. So my next question says the nitrogen detection in an organic compound is carried out by Lassaigne test. The blue color formed corresponds to which of the following formula? So this question came from a straightforward chemical reaction, which is the qualitative analysis of nitrogen. So in this case, if you remember this formula, you can easily understand the question and you can easily answer this type of question. So in this case, in qualitative analysis of nitrogen, we use sodium hexacyanoferrate and we treat it with iron sulfate, and then we get ferric ferrocyanide. So this molecule along with another sodium sulfate. So this ferric ferrocyanide molecule comes as a Prussian blue color, and that's this is the detection method, qualitative detection method of nitrogen. So option B is the right answer. So my next question is from a quantitative analysis of nitrogen. We have already discussed it. This is Dumas method. So I have already told you that quantitative analysis of nitrogen can be done 2 ways. The first one is the Dumas method and the second one is the Zeldal method. So the next question is a numerical question from the Dumas method. So let's start this. So in Dumas method, for the estimation of the nitrogen, 0.25 gram of organic compound. So the M, the mass of the organic compound that has been taken is 0.25 gram. And the volume of nitrogen we got is 40 ml. So I have written it V equals to 40 ml. And the temperature at which the reaction is being done is 300 Kelvin. So temperature equals to 300 Kelvin. Pressure that is being used is 725 mm. Now in this case, the aqueous tension at 300 Kelvin temperature is 25 mm. So we know that when the pressure of nitrogen is different from the atmospheric pressure, we get the actual pressure of nitrogen by subtracting. We get actual pressure, that is, I'll denote it as P1. We get the actual pressure by subtracting this pressure minus aqueous tension. So the actual pressure of nitrogen will be 725 minus 25 equals to 700 mm. Okay, so we got the actual pressure. Now we will find out that at STP what is the volume of nitrogen we got. So the formula to find out the volume of nitrogen at STP is volume of N2 at STP is P1 into V into 273 divided by 760 into temperature. So in this case, the P1, that is the actual pressure, is 700. So in place of P1, I'll put 700. So the volume in this case is 40 ml. So I'll put 40 in place of V. Directly I'll put 273 and then below I'll put 760. The temperature is 300 Kelvin. So the temperature I will put is 300 K. So after calculating this value, we get 33.52 ml. So after this, we got our volume of nitrogen at standard temperature and pressure equals to 33.52. Now moving to the next section. So it says 22,400 ml of nitrogen at standard STP, like standard temperature pressure, weighs 28 gram. Now we don't have 22,400 ml of nitrogen, we have only 33.52 ml. So we have to calculate it in such a way that 33.52 ml of nitrogen at standard temperature and pressure contain 28 by 22,400 into 33.52 gram of nitrogen. Now if we are being asked the mass of the nitrogen that we have found, we can find out from this value only, but we have been asked the percentage of the nitrogen that we got. So in a simpler term, you can take a screenshot of this one. I am rubbing this one. You can pause the video and take a screenshot of this. So we have been asked the percentage of the nitrogen. So the easiest way to remember how to calculate the percentage is taking the mass, that is 28 into 33.52 by 22,400 and multiplying it with 100 by m. Now what is m? The m is the amount of or the mass of organic compound that we have taken at first. So in this case, the value of m was 0.25 grams. So I have to rub this m and I have to put the value of organic mass that we have taken. So this is the value of the percentage of nitrogen content. So after calculating this value, we get 16.76%. So option A is the right answer. So my next question is again from Dumas method. If you haven't followed the Dumas method and how the numericals can be solved, so you can check from this method, like this is another question from Dumas method, you can easily understand from this one as well. So it says, in Dumas method of estimation of nitrogen of 0.3 gram of an organic compound, so the organic compound we have been given is 0.3 gram. I have written it with m. Now from this method we get 55 ml of nitrogen. So we got, I put the value of the volume of nitrogen as V equals to 55 ml. And the temperature at which this reaction has been done is at temperature of 300 Kelvin. After that, the pressure of this reaction was 715 mm and the aqueous tension was 15 mm. So our first work is to find out the actual pressure of the nitrogen. So for this, the actual pressure is P1 equals to the pressure given minus the aqueous tension. So the pressure given was 715 minus 15 because the aqueous tension is 15. Now from this we can calculate that the actual pressure is 700 mm. Now our next work is to find out that the volume of the nitrogen at STP. So for this we have a formula. The formula is the volume of N2 at STP. So the formula is P1 into V into 273 divided by 760 into temperature. Now in this case, the P1 is the actual pressure of the nitrogen. So we can put P1 equals to 700 mm. After that, V, the volume in this case is 55 ml. So I have put 55. After that, 273 and below there is a 760 into temperature is given 300 Kelvin. So from this calculation we get the value of 46.099 ml. So we got the volume of nitrogen gas in STP is 46.099. Now we have to find out the percentage of nitrogen in this case. So for percentage of nitrogen we have the formula. The formula is 28 into V by 22400 into M. Now in previous question I have elaborated how I have derived this one, and this is the shortest method. You can easily put this formula. If you can remember this formula, it will be very easy. It will take much shorter time. And if you don't remember this formula, we have elaborated how we got this formula in the previous question. In that way also you can remember it. So I will directly put the values in this formula. This is nitrogen percentage. Okay, so 28. Now we got the value. We got the volume of the nitrogen, that is 46.099 ml. So this is 46.099 divided by 22400 into M. Now M is the mass of the organic compound that we have taken at first. So this is 0.35. Now by calculating this we get the value 16.45. This is the answer of this question, and option B is the right answer. So we have completed all the questions from last 30 years in quantitative as well as qualitative analysis. In case of organic compound there is no other question left, and if you find out any other question from in this context like qualitative quantitative analysis or general organic chemistry, you can easily text me or like send me in the comment section or send me the question in Instagram. I'll definitely try to answer it, or I can make a separate video on those questions and I'll answer all of your questions. So thank you for joining me today. For more content, please stay tuned. And if you haven't watched my previous videos, you can go to my I section or you can directly search in my name. You can find out all the other previous videos that I've uploaded in this context. You can easily see them, and if you see any problem or if you find difficulty in understanding, please write me. I'll be very happy to answer you. Thank you everyone.